Okay, so the sign of the first derivative is given by minus and x squared minus 2. No problem. In this, I will plug in 0 first of all. And when I plug in 0, I get positive. And between the square root of 2, which is 1.4, and 2, I could plug in 2, although it's undefined, but it's undefined because of the denominator. But I want to study the sign of the numerator. So, but I'm having some difficulties because, oh no, I don't, it's 2 squared. So 4 minus 2 is 2 with minus in front will be negative. And the same thing here, that's 4 minus 2 with minus in front. Okay, so now I'm trying to make sense of these two rows. If they don't work well together, I'll say, oops, wrong, wrong, wrong. Let's see if that's the case. From 0 to negative 2, yes, it is decreasing. From negative 2 to 0, yes, it is increasing. From 0 to 2, yes, it is increasing. From 2 to 0, yes, it is decreasing. Well done. Yes, now the second derivative is even worse than the first. Why? Because it's a rational function and it has a denominator that is a square root. So it's messy, quite messy. Let's give it a shot. And then we will not let Hirsch choose other problems. I'm kidding, I'm kidding, I'm kidding. So f prime is negative 2 and the top is x squared minus 2 over the square root of 4 minus x squared. Okay, so the second derivative. You know me, I'm not going to involve this. I have enough on my plate. So the top prime is 2x times the square root. And then minus the top. But now that's the problem here. The square root prime. 1 over 2 the square root of 4 minus x squared multiplied by the inner function prime. I'm going to put it here at the top. Now the denominator is nice because I have to square that and I get 4 minus x squared. At least that. Okay, I'll try to simplify. So I will simplify this 2 with this 2. I see there is a negative here and the negative here that will change into positive. And also, I will factor out x from these two terms. Out. So the least common denominator will be 4 minus x squared, with the square root, of course. So then this one needs a 4 minus x squared with the square root. Okay, so x is out. 2 is still in. So 2 multiplied by 4 minus x squared. Now this is out. 2 is out. The negative it's out because it's negative and negative. So plus x squared minus 2 over this. If you want, over 1, because I'm going to flip the denominator. Not friendly calculations. Okay, so 8 minus 2x squared plus x squared minus 2. Okay. Negative 2x outside. Negative x squared. Yes, and then plus 6. Out with a negative sign, of course, again. And then I have x squared minus 6 over 4 minus x squared, and the square root of 4 minus x squared. When I said the second derivative equal to 0, there are 3 possibilities for the numerator to be 0. X X squared minus 6 could be 0. A fraction is 0 only if the top is 0. There are three possibilities. X to be 0, and then x squared equals 6. X equals the positive square root of 6, and the negative square root of 6. So 3 pages ago, I guess, yeah, I had my table. Okay. Negative the square root of 6. Is it less than 2? Yes, it is less than 2. No, it's not less than 2. Ah, nice. I love that. The square root of 6, the square root of 6 is more than 2. Yes, it's 2.44. Yay, so those are not in the domain. Nice. So I only have to deal with 0. Yay. So now in the second derivative, what I will not plug in is this. This is all positive. And the 2, I don't care. I'm only going to plug in an x squared minus 4, x squared minus 6. This quantity between negative 2 and 2 is always negative. Or just let's plug in some numbers. Let's plug in negative 2. This is negative, but this is also negative. So 4 minus 6 is negative, so this side is negative. So now I'm going to plug in the other side. Let's say 2. So 4 minus 6 is negative. 2 is positive. So this is positive. Ah, a sigh of relief. And this is an inflection point. 0, 0. It's actually a nice function. It's also symmetric with respect to the origin. Very good. Okay. I think we can move on because we're going to have other functions. I guarantee you 5, 6, and 7. We're going to have other functions like rational, or we can look at a rational. If you say, yes, no, let's see a rational, we're going to use the table again. But if you want to see a rational, we can look at a rational and then look at a word problem and then build a function. I think I'm on 8, am I not? Yes, I'm on 8. Anyone will like to choose a rational now, or not now, but later? Or so I don't know if is anyone listening? Am I just talking to myself? Anyone? Please? Anyone? No? No one wants to talk to me today? Okay, then. So what do I do?
45.
Okay, 45. 45 it is. I was going to say, do you want to study this on your own? And my hope was that you would say, no. We want to study this with you. Okay. My wishful thinking. Okay. So we want to do exactly the same thing we did. We want to fill out the table. We want to find the limits. We want to, etc., etc., etc. Okay. Can anyone give us the domain of this function? Do we understand the table? If anyone is watching or following, do we understand how we determine and how we fill in the table? Anyone?
I get it.
Okay, I really hope so because it's extremely useful. Can anyone give us the domain of this function, please? Is there any danger? Can this function be undefined for anything? It's a rational function. My only concern is the denominator. But the denominator cannot be 0. No matter what you do, this function will be very unlikely, but obviously defined everywhere. Good. So I will put 0 in. I have to. When I plug in 0, I get -4 for the function. And I want to determine these limits. Very important. It's the end behavior of the function. So limit as x approaches infinity from -4 over x squared plus 1, and limit as x approaches negative infinity from -4 over x squared plus 1. Can anyone tell us how much are these? And no, don't try to use L'Hopital's rule because this is not infinity over infinity or 0 over 0. Anyone? Well, the denominator is so big that -4 when I divide by something very big, the answer is 0. -4 when I divide by infinity, the answer is 0. So we know that if that's the case, we know that y equals 0 is a horizontal asymptote. So 0 and 0. Okay. Now I will have to determine the sign, the first derivative, set it equal to 0, etc., 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 etc. Okay. So f prime, you know I'm not going to involve -4. And I'm going to change this into x squared plus 1 to -1, of course. I bring down -1 and I have 4 times x squared plus 1 to -2 times the inner function prime. So the first derivative looks like this. 8x over x squared plus 1 squared. Is f prime undefined? No. It's defined everywhere like the function is. Is f prime 0? Yes. Yes, a fraction is 0 when the top is 0. In the next step, I will have to study the sign of the first derivative. But not this. This is always positive. And not this. Who cares about 8? The sign is given by x. If x is negative, the first derivative is negative. If x is positive, the first derivative is positive. So good. So from 0 to -4, the function is indeed decreasing. Yay. And it's supported by the sign of the first derivative. From -4 to 0 is increasing and supported by the sign of the first derivative. Obviously, 0, -4 is a local min. At this point, I will investigate the second derivative. And I will use the first derivative. It's my page 9. So the first derivative for me is 8x times x squared plus 1 to -2. You can say, I want you to use the quotient rule. I can use the quotient rule. Let's use the quotient rule if that's what you want. So 8 can wait patiently. I'm not going to involve it. The top function prime is 1. So then x squared plus 1 squared minus x times the denominator prime, which is 2. X squared plus 1 to 2 minus 1 times the inner function prime, which is 2x, over x squared plus 1 to the 4th power. The key word here is factor. I will definitely factor in order to simplify. So I have 8, common factor x squared plus 1. And yes, and some of you forgot to do this. You got some credit, but you forgot to simplify. So let's see what is left. So I took an x squared plus 1 out, so there is still 1 inside, left inside. So this is out. So then I have 2x times 2x, which is 4x squared with minus in front. Any questions so far? Okay. So then we have negative 3x squared plus 1. Negative 3x squared plus 1 over x squared plus 1 to the third. Or negative 8, 3x squared minus 1 over x squared plus 1 to the third power. Okay, so the second derivative is 0 when the top 3x squared minus 1 is 0 or x squared equals 1/3 ugly plus or minus the square root of 1/3. But it is what it is. I have to go back. Plus or minus the square root of 1/3. I will study the sign of the second derivative. Not here. This is always positive. Not going to waste my time. And not in 8. I don't care. Right? So when I plug in 0, sign is positive, which makes this. And then outside, I'm going to plug in 10. 10 squared, this is positive, but there is a minus in front. If I plug in negative 10, it won't make any difference. It's still negative. Obviously, this is an inflection point, but I did not plug it in the function. I have to plug it in the function. So can I do this without a calculator? So it's going to be 1 over 3 plus 1. Yeah, I can. It's easier without the calculator, actually. So f of plus or minus the square root of 1/3, doesn't matter, is negative 4. It's a even function, so it doesn't. It's going to be the same number. So it's 1/3 plus 1. So this is negative 4 times this is 4 over 3 or 3 over 4. Nice. Negative 3. Checking. Yes, negative 3 for both. Okay. So these are the inflection points. The square, negative square root of 1/3, comma negative 3, and the square root of 1/3, comma negative 3 are both inflection points. Any questions?